All right, so I'm only going to go through 4 problems in this video, and each problem is pretty much covering everything that you'll need to know for the test. So I'm not going through every single problem, but each type. So for this one, you will be asked to determine, check for normality. So you need to see, will this data produce a normally distributed, is this data normally distributed? So the first thing you have to do is you need to rearrange these numbers from least to greatest. So I'm going to go ahead and do this now, and I'm going to pause the video and fill this in. All right, so I went ahead and I rewrote this data so that it's in the correct order from least to greatest. All right, so now what we need to do is we need to go ahead and we need to create our frequency distribution. So that is with our class limits, our class boundaries, and then our frequency. In order for us to do this, we need to first figure out how many classes do we want. On your test, I will tell you. So here there's 16 pieces of information. So I'm just going to say go ahead and make your classes of 6. That's what we did in class. So we take our largest number and we subtract our smallest number. So 4605 minus 980. And then we divide it by the number of classes that we want. And that is then going to be, that is 6. How many classes? So then we do 4605 minus 980, we divide that by 6, and we will then get 604.12. No matter what, you always round this up, so we are going to use our class size of 605. So then we fill in the smallest number, 980, and we add 605 to it, and then we subtract 1, so that gives us our class of 1584, our highest limit of 1584. All right, then we're going to do this for the rest of our classes. From each of these, we can just add 605 to it. All right, so I know I didn't have that much space, so I tried to write as best I could. If you're not sure of these numbers, just send me a message. But this one's 4004, and you know all of these green numbers are going to be 1 less than this anyway, because the highest limit has to be 1 less than lowest. All right, then we're going to go ahead and fill in our class boundaries. So we would take this 980 and we subtract 0.5, so it's 979.5. And then we take this 1584 and we add 0.5, so it's 1584.5. This highest one, because we'll subtract 0.5, so it's also 1584.5. And then we add 0.5, so it's 2189.5. Right, then we're going to do this for the rest of the table. All right, then we're going to go ahead and fill in all of our frequency. So then we will look, how many numbers do we have between 980 and 1584? So 1, 2, 3, 4, 5, 6, 7. So we have 7 numbers here. Then our next one up until 2189, so 1, 2, 3, 4, 5. The next one, 2794, we have 0. The next one, 3399, we have 0. Then the next one to 4004, we have 1, 2, 3. And then the last one, we have 1. All right, then I'm going to move down. After you create this chart, this distribution frequency, you need to go ahead and you need to create your histogram. So we draw our y-axis and our x-axis. Our y-axis, the highest number is 7, so we're just going to count 1, 2, 3, 4, 5, 6, 7. And then along our x-axis, we need to write the class boundary. So the first one will be 979.5, and then the second one will be 1584. I'm going to write these like on top and below each other so that way I can have space. And then we're going to fill in the rest. All right, so it's our class boundaries, and then this is our frequency. And now we draw our tables. The first one had a frequency of 7, so we go up to 7. The second one had a frequency of 5, so then we can go up to 5. Sorry, had a frequency of 5, so we can go to 5. Then the next one had 0, so we don't have to put anything, 0. Then the next one is 3. And we go up to 3. And then the last one had a frequency of 1. All right, so the first part of this test to see if it's normal or not is to visually, how does it appear? So remember, if we have data that's normal, it's going to form this bell curve. Well, clearly this is not normal. And if we were to try and draw this curve, it actually is increasing as we move to the left, and most of our data is going to be to the left. So this looks like that is going to be skewed to the right. Right? But visually, we're just saying it looks like or appears like it's going to be skewed to the right. So now what we do, right, this is going to have to be made in multiple videos because you see this line is going to be stuck there now. So I'm just going to have to do this in this little space here. Now what we do is we create our Pearson's index. So our Pearson's index, and that is equal to 3 times the average minus our median divided by our standard deviation. So then we can type this all into a calculator. So we will type all of this. Okay, we're good now. So we can type all of this. We will type all of this into our calculator. All right? Goodness. It's driving me crazy. So all of this into our calculator. So I'm going to type this in now, and I'm going to get our average, our median, and our mean. All right, so now in order to find this, you are going to type all of that data, like I said, into your calculator, and then you will go to, so you'll go to Stat, then you go to Edit, and then you will type all of our data into one of your lists. So in this case, I did mine in list 1. All right, then you go to Stat again, then you go to Calculate, then you go to One Variable Test, and whatever list you did, make sure that you only have one list. So for our list, if it asks for a list, you will type in L1 since that's what you put. And for frequency, make sure that you have nothing in it. So you would delete it, so it would be nothing. And then you press enter, and it will give you your information in which your X bar, your average, is equal to 2136.1. Your sample standard deviation is equal to 1171.7. And it gives you your median as well, and it tells you that that one is equal to 1755. And then you type it into this equation. So our PI is equal to 3 times our average, 2136.1, minus our median, which is 1755. All divided by our sample standard deviation, which is 1171.7. And then that gives us a value of 0.98. And remember, after we get this, we are then going to compare this. In order for this to be normal, it must be between -1 and 1. And this is less than 1. So you may want to look and say, well, this is going to be normal because 0.98, sorry, I wrote this wrong, 0.98 is less than 1. However, it is almost to 1. It's almost equal to 1. And when we look at this visually, it tells us that it's going to be skewed to the right. And this tells us it is really close to being equal to 1, which then means it's not normal. So when we compare the two, we would say that this value or this distribution is not normal. All right, because visually it does not appear to be normal, and our Pearson's index is almost equal to that 1, so we would then say, no, this is not normal. All right, let's move on to the next question. All right, so for this one, it says the average number of gallons of lemonade consumed by a football team during a game is 20, with a standard deviation of 3 gallons. Assume the variable is normally distributed. When a game is played, find the probability of using, and it asks you these multiple questions. So because it doesn't say we're taking a sample, we're going to be using a z-score of x minus m divided by our standard deviation. And remember, we are always going to be using this normally distributed chart that we have that I gave you guys that if you lost, you will need to print out for your test. See if I can just draw this a little bit better. All right, so now what we need to do first, it's saying find the probability of using between 20 and 25 gallons. So we need to calculate the z-score for 20. So what is our z-score when x is equal to 20? And what is our z-score when x is equal to 25? And when we calculate those z-scores, that will allow for us then to find the probability of using between them. So the first one, our z is equal to our x, 20, minus our average, which is 20, divided by 3, which is our standard deviation. So z is equal to 0 divided by 3, or our z-score is equal to 0. So then we look at our chart and we see that when we have a z-score of 0, we have 0.5. So that means this 0.5 is everything to the left of this red line. So I'm just going to rewrite this 0.5. So we found the average of this green area, or the probability or the area of that green shaded region. So now we need to go ahead and find when our z-score is 25. So z is equal to 25 minus 20 divided by 3. So z is then equal to 5/3, which z is then going to be equal to 1.67. So we will then look at our chart, look at our table for 1.67. And at 1.67, we are at 0.9525. So that means from all of this area here in between the two red lines and this green, it is 0.9525. So if I only want to find the area here where it's red only, I take the area of the larger number, 0.9525, and I subtract the smaller one, 0.5. So that means the area is 0.4525, or the probability of picking a team that will consume between 20 and 25 gallons of lemonade during a game is 45.25%, or 0.4525. All right, so that is for the first one. Since it's between, we had to go ahead and subtract them. All right, now I'm going to go ahead and erase all this so we can do B. All right, for B, it says less than 19 gallons. So same thing, we need to calculate our z-score first. So 19 minus 20 divided by 3. So z is then equal to -1/3, or our z-score is -0.33. So now when it's less than, this is the easiest one we could possibly do. We draw our line for our z-score, so -0.33. We then go to our table and we look up what is our z-score at -0.33. So that would give us 0.3707. And what makes this the easiest number possible is when we solve for the area or the probability when we're given the z-score, we are solving already to the left of it. And less than means to the left. So this is just simply our answer. So the probability of a team drinking less than 19 gallons is 0.3707. If you write it as percentage, 37.07%, I would also accept that. But that would be your answer. There's nothing else we need to do, because when we solve the area or the probability using our z-score, we're already solving to the left or less than. Let me erase this so we can do C. All right, then for C, it's saying more than 21 gallons. So we want to be more than 21 gallons. So same thing, we calculate our z-score. Z is equal to 21 minus 20 divided by 3. So our z is equal to 1/3, or z is equal to 0.33. Make sure you're rounding these decimals correctly and you're rounding to the hundredth. So now we draw our line, we write our z-score of 0.33, and now we calculate that. So 0.33 gives us a probability or an area of 0.6293. All right, but remember, when we find this, we find the area or the probability to the left or less than. And this says more than 21 gallons. So in order to solve for this, we need to say, all right, well, we want to solve for this area, right, this red shaded area. And we know that our entire probability adds up to 1. So if we subtract the area or find the complement of the probability of less than 0.33, that will give us the area or the probability of more than it. So that will give us 0.3707. So that means you have a 37.07 chance of getting more than that. All right. We're not going to do D because D will be the exact same thing as A. And for interest of time, just rework it out like I did for A. All right, let's move on to the next question. All right, so for this problem, remember, you're also going to be given two different z-score formulas. One is when you're dealing with just one score, and then the other is when you're dealing with a sample, which is z is equal to your average of your sample minus the average of your population over the standard deviation of your population divided by the number of samples, the square root of the number of samples. So when you're given these problems, which is very similar to the first one we did in this video, you need to be able to identify when am I given, I'm sorry, this is the wrong problem. This is not the one I was thinking of, sorry. So disregard what I just said here. All right, this one, it's working in reverse from what we did in the beginning one. We are given, it says the average thickness of books on a library shelf is 8.3 centimeters. The standard deviation is 0.6. If 20% of the books are oversized, find the minimum thickness of the oversized books on the library shelf. Assume the variable is normally distributed. So we want to figure out what value will generate that we will have a 20% area above or a 20% probability above. So what we're doing now is we're working in reverse from what we did on the first question. So when they say if 20% of the books are oversized, that means this 20% is the top 20% in size of books. So when we had the z-score that normally we would draw and solve for the z-score by doing x minus our mean divided by our standard deviation, but since we don't know our x, we need to work backwards to get our z-score. So we know that this is giving us the top 20%, which then means 80% score less than it. So we look at our chart, at our table, and we're looking, because this is the area, so we're looking inside. Out here is all of our z-scores. And this is our area. So when we're given the area, we look on the inside of our chart, and then we use this when we find the value that we want, then we use this to generate our z-score. So we want an area of 0.8. All right, so what we do then is we look in our z-score, or we look inside of our chart, and we look for 0.8. Now, since you're not going to get 0.8 exactly, you need to find two values that 0.8 falls in between. So that's 0.7995, and then the next one is 0.8023. Well, 0.8 is somewhere in between here, so you pick the one that's closest to 0.8. Well, 0.7995 is closer to 0.8 than 0.8023. And 0.7995 generates a z-score of 0.8, and this one up here is 0.04. So our z-score is 0.84. So now we know our z-score is 0.84. We don't know our x. Our mean is 8.3, and our standard deviation is 0.6. So now we solve for our x, and that will give us the minimum thickness for this oversized book. So we solve by multiplying each side by 0.6. Multiply each side by 0.6. So 0.6 times 0.84, that is equal to 0.504, is equal to x minus 8.3. We add over the 8.3, and that tells us that x is equal to 8.804 centimeters. So that means the minimum thickness that we can have in order for us to be in the top 20% oversized books is 8.804 centimeters. All right, one more question. All right, as I started to say before, this is what I meant, where you are given two different z-score formulas. Z is equal to x minus mean divided by standard deviation, and this is for when you have a singular score, or you're given one for when you're given a sample, and that is z is equal to the average of the sample minus the average of the population divided by the standard deviation of the population over the square root of n. All right, sometimes it will flat out tell you it's a sample. This one says if 12 ovens are repaired. So that means we're looking at more than one oven. So that tells us that this is a sample, even though it doesn't say the word specifically, sample. So then we're going to use this formula. So we need to solve for what our x bar is. That's the average of our sample. So it says find the probability that the mean of the repaired bills will be greater than 60. Well, this is if 12 are repaired, and they're saying that the average or the mean of the repaired bills is more than 60. That means that the average for a sample is $60. The average of the entire population, the average repair for a cost of a microwave oven is $55. So that means if every single microwave that gets repaired, the average cost is $55. It tells us the standard deviation is $8, and it says that 12 ovens are being repaired. So we will plug this into our formula. So z is equal to 60 minus 55 divided by 8 over top of the square root of 12. So when you type this into your calculator, you will get 60 minus 55 divided by 8 divided by the square root of 12. And that gives us 2.165 or 2.17. So we have a z-score of 2.17. So now we need to go ahead and look at our normal distribution, and we need to calculate, well, what is less than 2.17? So we look at the z-score for 2.17, and that gives us 0.9850. So that means 98.5% or 0.9850 of the samples we create will have bills that are less than $60. So of all the samples we get, on average, 98% of these will be less than $60. So it said what will be greater though. So we need to find this area here. So we would do 1 minus 0.9850. So that means that the answer is 0.015. So that means that's how many bills, or the percentage of bills, or the probability that the mean will be greater than 60. So we have less than a 2% chance that when we do this sample, that the mean will be less than 60. So it's very unlikely. All right, that is it for this video.